Welcome students to MOOC's lecture on fuzzy sets, arithmetic and logic. This is lecture number 28, and I discussed earlier that in today's class we shall discuss Mamdani style fuzzy inferencing, if you recall, so far what we studied is given a conditional or unconditional proposition and some information about antecedent variable x, what we can deduce for y, and we obtained a fuzzy set B prime for corresponding consequent variable y. In practice, we need a specific value for y, not the fuzzy set. For example, suppose a washing machine needs to infer about y, which is the speed of rotation. And suppose it depends upon several factors such as weight of clothes, quality of the fabric, etc. If y comes as a fuzzy set, then how to decide about the speed of rotation? So, you understand the problem. We got from the inferencing a fuzzy set B prime, which should give the membership for different values of y, but we need to choose one of them. How to choose that? So, Mamdani style scheme helps us to identify the value of y. Of course, there are other fuzzy inferencing schemes. For example, Sugeno's methods is very well known one, but in Sugeno's method the output comes in the form of a function of the input variable values. But in Mamdani's scheme, we get one specific value of y through a technique of graphical methods. Also, another point is there may be multiple parallel rules, and each rule has its own fuzzy set for the consequent variable. Therefore, while inferencing, we need to consider all the relevant rules to come up to a conclusion. So, typically the input will be the crisp values for the antecedent variables based on them we need to infer about the consequent variable. Pictorially, we have crisp inputs. There may be rule 1, rule 2, rule n, and in each rule we need logical operator and implication. Same is here, same is for them. Based on that, we get some fuzzy membership for some set F1, this gives for some set F2, and this gives for some set F3. Then we need to aggregate all of them, and from there we use defuzzification to get a crisp value for the consequent variable y. So, let us illustrate with an example. Suppose we have two antecedent variables one is the temperature, which we assume is in the range 0 degree to 30 degrees Celsius. Another is wind speed. And which can go say between 0 to 40 kilometer per hour, and output variable is what we call comfortability of the weather, which is a artificial variable taking values in the range 0 to 12. Suppose we have the following three rules. Rule 1, if temperature is low, or wind speed is strong, then weather is chilly. Suppose we have a rule 2, if temperature is fairly low, and wind speed is gentle, then weather is comfortable, and suppose rule 3 is if temperature is not low and wind speed is light, then weather is stuffy. Suppose the given input is temperature is 15 degrees Celsius, wind speed is 8 kilometer per hour, and we need to infer about the comfortability index which runs between 0 to 12. So, I hope the problem is clear. We have the input temperature 15 degree and wind speed 8 kilometer per hour. The problem is we have 3 different rules. Each rule has something to say about temperature and wind speed, and each rule gives a value for the consequent variable, which is the weather comfortability index, and that comes in different rules in different ways. Therefore, question comes how to infer from the given input. So, let us first consider comfortability. Let me call it comfortability index. It is defined on the interval 0 to 12, and we have defined three fuzzy sets on it. These three sets are chilly, comfortable, and stuffy. So, let us define them. Chilly. Suppose it is defined as follows: mu chilly of x is equal to 0 if x less than 0 or x greater than 12. It is 1 if 0 less than equal to x less than equal to 2, and it is 6 minus x by 4 for 2 less than equal to x less than equal to 6. Thus, it has the following shape. this is 2, this is 0 and this is 6. In the subsequent part, we shall call it half TRFN and we may denote it as 0, 0, 2, 6. In a similar way, comfortable is defined as 0 if x less than 2 and x greater than 10. It is linearly increasing between 2 to 6. Therefore, the membership is x minus 2/4 if 2 less than equal to x less than equal to 6 and between 6 to 10 it is going to be 10 minus x by 4 and as we know it is above 10 it is going to be 0. So, it is going to be having a shape something like this. This is 2, this is 10 and this is 6. So, this is going to be TFN 2, 6, 10. The fuzzy set stuffy is defined as follows. Mu stuffy of x is equal to 0 if x less than 8 and it is going to be linearly increasing in the interval 8 to 12. Therefore, it has the shape something like this. Note that these membership functions for the fuzzy sets defined on the consequent variable or are very important. And 2, these will be used in the final decision making. And thirdly, we will draw all 3 curves superimposed with each other in the following way. So, let us now draw the 3 curves. Let us now look at temperature, and suppose we have the following between 0 to 10, for low it is 1, and from 10 to 30 it is linear. Therefore, fairly low, as we know, we can use the square root and we may get something like this, and not low this line. So, this is not low, this is fairly low, and this is low. Let us now consider the other antecedent variable wind speed. Its range is, suppose in 0 to 40, basically they are kilometer per hour. Here too we have 3 fuzzy sets defined on it, which are light, gentle, and strong. Let us now look at this. Suppose light is defined as follows: mu light of x is equal to 1 in the interval 0 to 10, it is x minus 10 by 5 in the interval 10 to 15, and it is 0 if x is greater than 15 or x less than 0. Similarly, gentle is defined as follows: mu gentle of x is equal to 0 if x less than equal to 5, it is x minus 5 by 6 for x belonging to 5 to 11, it is 1 if x belongs to 11 to 15, and it is going to be 20 minus x by 5 if x belongs to 15 to 20, and it is 0 if x greater than 20. Mu strong of x is defined as, it is 0 if x less than equal to 15 and it is going to be x minus 15 upon 25 for x belonging to 15 to 40 and 0 if x greater than 40, because we have assumed that wind speed is in the range 0 to 40. Now, our given input value is 8 kilometer per hour. Therefore, we need to calculate its membership to all the three fuzzy sets we have defined above. And we have mu light of 8 is equal to 1, mu gentle of 8 is equal to half, and mu strong of 8 is equal to 0. In a similar way, we find out the membership values for the antecedent variable namely temperature, to the three fuzzy sets, and we have the following: mu low of 15 is equal to 0.75, mu fairly low of 15 is equal to square root of 0.75, which is we assume is 0.86, and mu not low of 15 is equal to 1 minus mu low of 15 is equal to 0.25. Now, we use these values for the three rules that we have in the domain, and let us see how we apply Mamdani scheme for coming into a decision. For Mamdani inferencing, we deviate from Lukasiewicz, in fact, for Mamdani inferencing, A implies B has truth value minimum of A comma B. So, in this approach, we use the above Let us now look at inferencing from the rules. So, what is rule 1? Rule 1 says that if temperature is low, or wind speed is strong, this implies weather is chilly. Now, mu low of 15 degree as we have calculated is 0.75, mu strong of 8 kilometer per hour is equal to 0. Now, we have a disjunction, therefore, we take maximum of them, which is equal to 0.75. Now, let us look at the comfortability index. Suppose this is 0.75. As these values come here, we get this. Therefore, up to this, the minimum of A and B is A. After that, it falls down, because this is less than 0.75, which we have got from the antecedent variables of rule 1, and therefore, when we apply the Mamdani inferencing, we get from the first rule that the original membership is clipped like this. Let us now look at the second rule, which suggests that if temperature is fairly low and wind speed is gentle, then weather is comfortable. Now, we obtained that mu fairly low of 15 degree is equal to 0.86 and mu gentle of 8 kilometer per hour is equal to 0.5. Since we have a conjunction and, so we combine them with the minimum, therefore, the value coming as an A from the antecedent variables is 0.5. Therefore, now we apply implication for A is equal to 0.5 for comfortable. So, we get the following. For these points, the comfortable value B is less than 0.5, therefore, it will remain there, but after that we clip the value because 0.5 is now minimum of these two, and after that it comes down along this line. Let us now look at rule 3, which says that if temperature is not low and wind speed is light, then weather is stuffy. As before, mu not low of 15 is equal to 0.25, mu light of 8 kilometer per hour is equal to 0.7. Since it is a conjunction, we use minimum, and therefore, the output coming out from these two is 0.25. Now, we again apply inference rule. So, we use 0.25 and because it is 0 till this point, this does not come into the picture. Therefore, after this what is going to happen? 0.25 is minimum, therefore, we get this line. Therefore, everything together, after all the clipping, we get this to be the fuzzy set. So, this is the fuzzy set that we obtain by using 3 rules. So, we summarize this finding as follows: by aggregating we get between 0 to 3 the membership value is 0.75, between 3 to 4 it is governed by this line and its equation is 6 minus x by 4, between 4 to 8 it is 0.5, between 8 to 9 it is given by the equation 10 minus x by 4, and between 9 to 12 it is 0.25. So, this is the membership values for the consequent variable the advantage of Mamdani scheme are the following. It is simple to understand. Two, solution does not require solving complicated mathematical equations. The visualization method allows us to see the effect of each rule on the consequent variable. Now, we need to use defuzzification for obtaining a crisp value for comfortability index. Now, defuzzification can be done in many ways. We discussed two. One is called center of maxima and the other is called centroid method. Center of maxima here, first we consider the height of the fuzzy set. Then we look at m is equal to infimum over all the y such that mu y is equal to the height, and also consider m which is supremum over all the y such that mu y is equal to the height. Now, looking at this graph, we see that the height of the clipped fuzzy set is 0.75 and the infimum is 0 and the supremum is 3. Therefore, by defuzzification, we take average of m and m, that is m plus m by 2, which in this case is 0 plus 3 by 2 is equal to 1.5. Therefore, if we use center of maxima, then the output is 1.5. But Centroid method considers the entire membership curve of the clipped set obtained as the membership for consequent variable, which in our case is the comfortability index. The formula for centroid method is on the entire fuzzy set A, we take the weighted average mu A x multiplied by x dx divided by integration over a mu A x dx. So, let us compute the defuzzified value for the above problem. So, this is the membership function. We are going to use it for the defuzzification. So, numerator is equal to 0 to 3 0.75 x dx, which is equal to 3.375. Then 3 to 4, 6 minus x by 4 x dx, which gives us 2.17. Then between 4 to 8, it is 0.5 x dx, which gives us the value 12. Then between 8 to 9, we have 10 minus x by 4 x dx, which gives us the value 3.17. And finally, between 9 to 12, it is 0.25 x dx, which gives us 7.875. Therefore, numerator is equal to 3.375 plus 2.17 plus 12 plus 3.17 plus 7.875, which comes out to be 28.59. In a similar way, we calculate the denominator, which is between 0 to 3.75 dx is equal to 2.25 3 to 4 6 minus x by 4 dx, which gives us 0.625. Then between 4 to 8 it is 0.5 dx, which gives us the value 2. Between 8 to 9 it is 10 minus x by 4 dx, which gives us the value 0.375, and finally between 9 to 12 it is 0.25 dx, which gives us the value 0.75. So, together when we sum them up, we get the value is equal to 6. Therefore, the defalsified value of the comfortability index is 28.59 divided by 6 is equal to 4.76. As you can well understand that the centroid method is more computationally intensive in comparison with the center of maxima method, but this gives a much more comprehensive value for the consequent variable. Note that there are many implication functions available in the literature. As I have discussed before, but still I give you a few names: clean lines, which say implication of A B is equal to maximum of 1 minus A comma B. Reichenbach, which is say implication of A B is equal to 1 minus A plus A B. Similarly, there are many but Mamdani's function is easy for visualization. Another important thing is that we have used clipping for aggregation of rules, but there is another method called scaling, which maintains the shape but reduces the values on the basis of the output of the truth value coming from the application of the rules. Okay, friends, I stop here today. With this, I conclude my topics on fuzzy logic. In the next class, I shall start the concept of belief and possibility. Thank you so much.